Hey everyone, how's it going? This is Siri and I'm back with another PyTorch video, and in this video we're going to be continuing our discussion on time series. If you recall, we were working on the bike sharing dataset, and also time series is just another form of tabular data, if you don't remember. And we went through what the different dimensions we actually wanted it to be. This isn't the actual dimensions. We wanted to modify it so that it is the case. And so we imported NumPy first. We loaded the text. We turned it into a NumPy ND array, turned it into a PyTorch tensor. We looked at the tensor and we looked at the data using pandas. And pandas is great for tabular data. It's one of the best, actually. You would probably only use pandas as the central tool if we were working with tabular data. And so we looked at the data a little bit. We saw what the different values were. We saw how why time series were important, and how identifying the relationship between different samples, with that relationship being the amount of time that's passed, is important, and it might tell us a little bit more information about what might be going on at the present moment or in the future. Because, just as an example, whether or not it was raining like an hour ago might certainly impact how many bikes were being rented, like right now, right? So that's why it's important to look at the time component if it's there, and we would use time series for that, okay? So how are we going to pass it into a neural network? Okay, that's the question. How would we pass it in to a neural network? Because remember, neural networks don't just take anything, right? They need it to be in a specific format. It needs to be able to understand what the data is, what it can do with the data. And you, just like an image, you can't just pass in a regular image that we can see. You need to convert it into a form that it can understand, which happens to be tensors, which is why people use PyTorch, right? And other deep learning frameworks that support these sorts of multi-dimensional arrays that we can store our data in. Okay, so how would we pass it into a neural network? Well, if you remember the cube that I showed you in the last video, and actually you don't even need to remember it from the video because I just searched it up, right? Just picture a Rubik's Cube, right? You see different, like a cube is basically just made up of different squares, right? And like with a certain width, and so each one of those layers were a different day. So that's what we want. And that would be the time axis, right? So we not only have like an X and Y, where Y would probably be the different columns, but we also have a time component, right? We need a third dimension, okay? So okay, before we get into that, this data that we have right here is 2 years worth of data, okay? We don't want to look at it like that. We don't want to look at like 2 entire years of data all at once, right? We want to break it up into chunks. And if we broke it down into days instead of those full 2 years, that would be great, right? That's what I was talking about, right? Breaking each layer into days instead of looking at it just as a regular cube without looking at the different components that make it up. So we could say that n is the number of samples, which is basically the number of days, right? So each day is a new sample, and we could have different channels, right? So in images we have a color channel. Maybe in time series we have like the different columns here, right? It's tabular data once again. So C, like the channels, so the 17 columns that we have, and which hour is it? So the actual, like even like breaking it down further into time, so we could have like an hourly component where I think you should go back to my previous video and just like maybe like fast forward it to the point where I describe where on the cube each like component here is. So I think that'll be a better visual. I'm not going to do it again, but yeah, you can imagine like samples, like the number of days is 1, the 17 columns are 1, and the time of day also matters, which we've described here, right? Like 1 dimension for different days, 1 dimension for different time of day, and the regular attributes. Okay? Great. So, and also, it'll be from 0 to like 23, which is basically the same as 1 to 24. So the 24 hours in the day. Okay? So each sample, basically, will have 24 different like pieces to it, right? So, for example, if you had images, maybe, and you didn't want to look at the entire image at once, you could break it up into like certain patches and look at those individually, like zooming in, and like you would have different patches for just one image. So similarly, you'll have different like pieces of your dimension just for one day, right? Because we have multiple hours in a day. So let's take a look at bike.shape. Did we create bikes? Yeah, the PD was just, just for our visualization. We're not actually going to be dealing with pandas, right? This is a PyTorch video. So let's take a look at bikes.shape if we didn't already. Okay, I guess I have to run this again. Okay. Okay, great. So we have these many samples across our 17 columns. Okay, we didn't break it up into days yet. Remember, we want to break up, insert cell above. We currently have 2 years worth of data. Okay, let's break it up into days. So it's not broken up into days yet. It's actually broken up into hour, I think. Okay, so the hour 0, 1, 2, 3, 4, right? And it's basically counting. So whatever number this is basically going to be the index, like the number of indices we have, right? So, I mean, it obviously repeats, right? Like 0, 1, 2, 3, and then 24, and then back to 0, 1, 2, 3, back to 0, 1, 2, 3, right? As soon as it touches 24, but you see the number of indices here, right? So if you add them in total, you're literally going to get these many hours. Okay, so we want to break them up into days. Okay, before that, let's also take a look at the stride. The function actually returns the value. Okay, 17,1. If you're not familiar with stride, size, and offset, I think you should check out my video on storage instances, because this is related to that concept, where we have, multiple tensors associated with one storage instance, and like that storage instance is just that contiguous train of values. And so like however many, it's always 1D, so however many elements you need to move across to get to the next row or next column is the stride. Okay, so you would need to move 17 to get to the new row, and just 1 to move to the new column. Okay, so that's that. And okay, so let's use something called dot view. Okay, so what does dot view do? Well, we said that we wanted to break it up into days, right? So let's break it up into days here. I'm going to copy it here. Okay. We'll use dot view. And what dot view is, and what dot view does, is that if you specify 2 dimensions that you're sure you know it's going to be. Okay, so we know we're going to have 17 columns, where we know we're going to have, you know, like a certain number of hours in a day, right? We don't want it to be these many hours. We want to look at how many days there are, so we need to be able to divide it by 24. Okay, so 24 is going to be a dimension. How many days are there? We don't know. I don't want to calculate. Like if we break it up into 24, right? We already know 2 dimensions, and we already know the total number of samples. We can obviously figure out the 3rd dimension, right? Because there's only one value that makes it true. If we have 3 dimensions, right, and we know 2 of them, but we know, and we don't know the 3rd one, but we do know how many it's going to be overall, we can figure out how many are going to belong to the 3rd dimension, right? So that's what dot view does. Okay, so let's say that daily bikes is equal to bikes. Okay, bikes is our tensor. Bikes.view. Okay, and what do we do when we tell PyTorch that we don't know how many dimensions? We don't know what the value of a certain dimension is, but we do know this other 2. What do we do with the dimension that we don't know? Well, we put a -1 there. We're saying, hey, PyTorch, I'm going to specify 2 more dimensions. You tell me how many dimensions are in this -1. This is just a placeholder value, okay? And you know, because the tensor that I'm talking about is bikes. You know how many values there are in bikes. And you know that if I want 24 hours and if I need 17 columns, you know the multiplication that will get you the total number of elements or like samples in bikes, right? So yeah, that's what daily bikes does. That's what dot view does. And let's take a look at daily bikes. Daily bikes.shape and daily bikes.stride. Okay, great. So now we know we have 730 days, we have 24 hours in a day, and we have 17 columns. But if you see now, we have a slight problem, which has an easy fix. But okay, so you see the 730, 24, and 17. It's not supposed to be in that order. Instead of like N by L by C, where L is the length, we need to make it N by C by L. So this is N, this is L, basically the number of hours, right? Okay, and the columns. So what we want is, we want the same 730, except we want the 17 to come next, and then the 24. Okay, so yeah, so how do we do that? Well, I think we went over transposing in another video. Definitely check that out if you want a more thorough deep dive into like transposing. It's another operation, tensor operation. Okay, so let's say that daily bikes, let's redefine daily bikes as the original daily bikes that we just defined above, but we're transposing it. And we can't use .t because we have more than 2 dimensions. So .t was the shorthand if we only had 2 dimensions. So so let's do 1, 2. And so what this does, if you remember, is that it swaps dimensions 1 and 2. Which is what we wanted, right? We can now swap 24 and 17, right? That's 1 and 2 because it starts at 0 and 2. So then we'll get 730 and then 17 and 24. So the last two swapped. Okay, that's exactly what we want, and it was a pretty simple function. Okay, and now let's check out dailybikes.shape and dailybikes.stride. Same thing as before in the previous cell. So now the dimension swapped. Great. Well, that's what we really want. And also the stride swapped. So the way that you need to move around in the storage changed. Okay. So again, for more information on storage instances and the storage module, refer back to my storage instances video. Okay. Great. So just for the sake of complexity, rather simplicity, right? Let's just focus on the first day. Okay. For simplicity, forgive me if I said complexity. Okay. For simplicity, let's focus on the first day. Okay. So let's create a variable that's going to store the information for the first day. And, you know, let's say that it's bikes up to 24, right, dot long. And don't worry, we will do this with daily bikes as well. But bikes, like, okay, so this means that we're gonna get the first 24 rows, and the number of columns is like the entire thing, right? Because that's implicitly said, since we didn't provide any value for the number of columns. Okay, so let's print out first day dot shape. And if we print out the first day dot shape, we get 24, 17. Okay. And so, wait, first. Okay, good. The reason why it's 24 is because we, like, specifically said to print out 24, right? And we have 17 columns. Okay, great. So the reason why we don't need daily bikes is because, first of all, we're only focusing on the first day, so it's not going to be repeating itself, right? We're not going to be like 0, 1, 2, and then to 24, and then going back to 0, because we're only focusing on the first day. If we were focusing on the first 2 days, then we would go back to the 1, and that's when, like, daily bikes would be relevant, but we're only focusing on the first 24 hours. So, yeah, so, okay, let's focus on the weather attribute. Okay, let's practice our one-hot encoding that we've talked about, and let's talk about how we can apply that to this situation. Okay, so let's say that weather one-hot. Okay, I'm not focusing on all of the attributes. Okay, don't get confused. I'm not like focusing on the entire thing. We're just trying to manipulate the data, getting a feel for the data, and trying to put it in a form that we can use to like pass into a neural network. Right? We're not focusing on manipulating everything. Let's just get a feel for how we do it, right? And let's do that with weather. Okay, so let's say weather one hot is equal to torch.zeros. Okay, if you don't know what one-hot encoding is, once again, check out my video on one-hot encoding. It's basically, it's not too complicated, right? We just assign numerical values to each of the different classes that we're looking at, and they're not just scalar values, they're vectors. And so the vector is going to have as many zeros as, or as many values as the number of classes there are. So if we had 4 classes, if we had an elephant, a giraffe, a porcupine, and like a rhino, right? Each one of them, how does the model distinguish between the 4? Well, each of those 4 are given different vectors. They all have like 4 values, and the way we tell the difference is that at a specific index value, at a different specific index value for each one, we're gonna place a 1 or like a non-zero term. So yeah, but if you need more information, if you need more clarity, feel free to check out the one-hot encoding video. Yeah, I think I explained it in more depth there. Okay, so torch.zeros, and like first day dot shape 0, right? 24 hours. And 4, because weather only has 4 distinct values. They're ordinal values. Okay, let's keep that in mind. And once again, categorical, ordinal, and continuous values are values that I discussed in my first tabular data video. They explain the scenarios in which you might want to use one-hot encoding and the situations in which you might not, right? It doesn't apply to every situation, obviously, right? So, but these are ordinal values because they tell you the order, but the difference between them doesn't matter. Like, it doesn't tell you, like if you have the weather, right? You can actually have 1, 2, and 3 and 4, like with 0, I think, being like the worst weather and 4 being the best. Or it might be the other way around. And no, actually, with 1 being the best and 4 being the worst. Right? Okay, so yeah, they tell you, right? Like the order, whether like this is better, if 4 is better than the first weather, like whatever, right? It tells you the intensity of the weather, but it doesn't tell you by how much, right? So that's where continuous values come in. So, okay, enough of that. But certainly if you need more clarity, if you need more information, feel free to check that video out. Okay, so what should we do now? Okay, let's print out first day, all the rows. Okay, so for each hour, and let's print out the 9th column because we're dealing with weather, and weather is the 9th column in the entire data set. Okay, so weather is 9th column. Okay, and we're printing out all the rows. So you see here, in the first day, the weather isn't like, it doesn't get too terrible, right? Maybe like the 3rd day or 5th day or like 100th day, maybe like you'll see some bad weather there. But it's not too bad, right? We have some pretty good weather. We see a couple of 3s, but mostly 1s and 2s. Okay, so we learned that we use the dot scatter in place method or in place operation to implement this one-hot encoding, right? So let's do weather one hot, right? So the steps are like you first create the tensor of zeros and then you apply the dot scatter method. Okay, so dot scatter in place. So I'm not just going to be returning a tensor that has this operation done onto weather one hot and that it's a completely separate tensor. No, I'm actually modifying weather one hot right here. So that's what the underscore means. You'll see it in other methods too. So that's PyTorch's way of letting you know that you're actually modifying the tensor in question and that you're not just returning a new tensor with those modifications. Okay, so we're going to scatter our 1s. Okay, by the way, it can be any other value, but we stick to 1s for convention. Okay, so we're going to do it along the first dimension. And because if you take a look at whether, actually we don't need to print out the dimensions, right? We define them right here. So dimension 1 is the 4, right? So we're going to be scattering it along that dimension. And the index is going to be the first day, and the 9 that we were talking about. And we're actually going to do some unsqueezing here. So what this does is that it creates an extra dimension of 1 at the specified dimension, which is the first one. And so let's convert that to a long. Okay, and let's do -1, because, you know, whenever you have indices, you might be dealing with a -1, because we deal with a 0-based index, obviously, right? So, and the value that we want to scatter is going to be 1. We could also do 8, 8.7, but like I said, we stick to 1.0 for convention. Okay? Okay, so it automatically returned it for us. So you see what I was talking about, right? One-hot encoding, you have each of the days, or each of the hours rather, because this is just dealing with the first day. We're dealing with vectors that each have 4 values, because they're 4 different values the vector that the weather can have. And so at a specified index, we let PyTorch know what kind of weather it is. So if you always see a 1 at the first index, it's probably 1. If you see 1 at the second index, it's always going to be 2. So you see a bunch of 2's here. If we see it at the third index, then it's a 3, and so on. Okay? So that's how it works. And so let's concatenate it to our original data set. So now we have daily weather 1 hot. Okay, so we're incorporating both elements, the daily part and the weather 1 hot encoded part. And let's do torch.zeros again. Okay, so this time we're going to have daily bikes dot shape 0, comma 4, comma daily bikes 2. What is 2? What is the shape of daily bikes? 24. Now we're doing it for each of the hours. Okay? So we're not only doing it for, the first day, we're doing it for every day. Okay? And daily bikes shape 0, 730 days. Okay, just 4, because we're just dealing with weather. We're not dealing with all the columns. If we were, then, it would be a bunch, right? So, and the 24 hours. Okay, so now we went full circle here. Okay, and we say daily weather. Let's just print out the shape again. Okay. Dot shape. Oh, we didn't concatenate it yet. Excuse me. So that's going to be the second step, because we don't have, okay, so let's do torch.cat. This is concatenating it, so it just smushes it together, either in the either column-wise or row-wise, and you can specify that when you're specifying the dimension. So bikes 24. Okay, weather 1 hot. Is it weather 1 hot? Yeah, 1 hot. Okay. So we're going to be concatenating these two, okay, along dimension 1, so column-wise. And let's get it up until the first row. Okay, so if we print it, Okay, wait, I'm curious if we... Okay, we're getting a lot. Yeah, so it was just some regular slicing here. Yeah. So now if you run this... Oh my goodness, I didn't do dot shape. I just said that this was a tensor. Oh my goodness. Okay. So now if you run it, it should... Okay, wonderful. So great. Okay, so now we're basically doing the same thing as we did before with the scatter, except now we're just doing it with daily weather instead of the weather for the first day. Okay, so daily weather, 1 hot dot scatter. Okay, in place, 1 daily bikes. Okay, all the rows, 9th column. Okay, so now we have a third dimension, so all the hours as well. So convert it to a long again. Dot and squeeze. Okay, 1 minus 1. We want to scatter it with 1s, 1.0s, and we run it. Wonderful. We can also concatenate this along the C dimension as well, like we did with the other one. So daily bikes is equal to torch.cat. I want to concatenate daily bikes and daily weather 1 hot along the first dimension, which is just stacking it. Not stacking it, I mean like putting it together column wise. Okay, great. And last step, I'm gonna move through this fairly quickly, which is just the normalization and rescaling the variables. You can either map their range from 0 to 1, or you can subtract the mean and divide by the standard deviation. So map range to 0 to 1, or you can subtract mean and divide by STD, standard deviation. Okay, normalization. Okay, and so let's say temp is equal to daily bikes. Okay, 10, it's a 10th row, 10th column, and yeah, temp min is equal to torch.min temp, temp max, which you can expect to be torch.max temp. Okay, daily bikes, okay, daily bikes 10, okay, minus temp.min divided by temp max minus temp min. Okay, so this is the rescaling that I'm talking about. 1 second. So 2 here. 1 here. Should I have another parentheses? Okay, 1. Where does this one? Okay. Okay. Oh, if we put these in parentheses too. Okay, great. And yeah, so that's a rescaling. Another way to do it is, basically the same thing. And we say daily bikes. is equal to the same thing, except instead of subtracting by the min and dividing by the max, what am I doing? Okay, and dividing by the difference between the max and the min, we are going to subtract the mean temp and, to divide by the standard deviation. Okay, torch.std temp. Okay, just a separator. So this is the second way. This is the first way. Okay, run it. Daily bikes is not oh. Did I say daily bikes? Okay. Okay, so we have temp is equal to daily bikes. That's right. Temp min is equal to the temp min. Temp max is equal to the temp max. Daily bikes, that's right, because we're referring to the right column. This is right. This is right. Problem's not here, actually. This is right. Right. I said temp.mean instead of torch.mean. Okay. Great. So, yeah, this is the normalization. We went through some manipulation, how to do some one-hot encoding, and working with time series. Okay, so yeah, we went through a lot in the past 2 videos, and I hope you learned something new. And yeah, I'm looking forward to seeing you next time. Next time we'll be talking about representing text and some natural language processing. It's just gonna be an intro, but you can look forward to that for next time. Okay, thank you so much. I hope you learned something, and don't forget to like, comment, and subscribe.